Hey, yeah, you better participate.
Yeah, I
Oh,
better be participating. Yeah, so I want to welcome everybody. I got Jesse popping in. So Jesse Maddox. Hope everybody had a great long weekend. If you keep up with sports, you know that the Lightning just won the Stanley Cup, which is the probably the toughest thing in sports to do.
yes.
Okay, so if you're a hockey fan, you probably enjoyed that last night. I know I did. No sleep, so
I,
very excited. What, Marsh?
my, my mom and I watched the whole thing.
You watched the whole thing?
Yeah.
I actually went to Amalie on Friday night. My buddy has season tickets, and they opened it up for like 1,500 people, so it was pretty cool. So, all right, we have.
You got to go inside there?
Yeah, actually inside instead of just the regular viewing outside, an actual ticket inside. So he invited me last night, but you got to work the next day, pull a 12-hour shift, ain't happening. So again, welcome everybody. This week we looked at, and I will screen share real quick. We were looking at social studies, right? And we'll just get right into this, dig right into this. We're going to do part of this on here. I'll preview your article that I want you guys to read. One of the two articles I want you to read this week on social studies in particular. So social studies, we're looking, and we looked at all of this before. We even marked up some of this stuff about understanding geography. We got into this section on Ecuador and the equator. We're going to look this is going to be kind of like our little mini lesson on this deal, talking about specifically understanding little map components. We're going to look at this and then add to it. I actually have a whiteboard in my room, so we'll be trying to do that as well. So let's go with it. When you begin to analyze maps, and you have this if you printed it out, or you can just follow along because you guys can see my screen, right?
Yes.
Okay, cool. When you begin to analyze maps, you must first understand map components, okay, or basically parts of a map. Maps often include the following scales, okay? We're going to look at, have small marks that stand for miles and kilometers. That's this guy down here. That's a scale. I just highlighted it for you. Then we have number 2, lines of longitude and latitude. And we'll discuss what those are, what they measure, okay? And they're used to find the exact or absolute location of places. Lines of longitude run north and south, and they measure east to west, but lines of latitude run east and west, and they measure north to south. So we'll get into that. Then we're talking about relative locations, okay? That's like Highway 52 is north of Highway 54. That's a general location, okay? Sheila's popping in. I'm just getting more attendance as people come in. Then, as we go through, we are looking at symbols such as dots for cities, stars for capitals, icons for special events, such as battles, okay? Sometimes you'll have topography. You'll be able to say mountains, valleys, things like that. As you look at like topographical maps, we'll discuss that. Then we're looking at symbols are explained in the map key. This is the map key. I will highlight it. We only have, again, this is just a simple map of New Jersey, where we have major cities and then a state capital. So Trenton is the state capital, and then all these other cities. Then you have in color coded the Atlantic Ocean, and then Pennsylvania, New York, Delaware, things like that, okay? By mastering the skills of understanding map components, you will improve your study and test taking skills, especially as they relate to GED social studies. So we're going to, when you start to analyze a map, examine all of the components such as the title key. Again, we want to know New Jersey. Sometimes we skip this stuff in the major cities in New Jersey, okay? If it said New Jersey and topography, you'd see that there would be mountains here, okay? Got my free Dunkin' Donuts, by the way. Before the day ends, free medium if you go in and make a purchase, because it's National, what do you call it?
Coffee day.
Coffee day. Moving on to B, use the map scale to measure the distance between cities. So you can look at this scale and see that on the top we have 0 to 25 or 0 to 50 miles. Okay, you can see that this almost fits from Camden to Beechwood. You have about 50 miles. Okay, that's almost the same if you can do that. So in the area we're looking at, which area of New Jersey has the most major cities? Is it the Northwest? Okay, which would be up here. That would be the Northwest. The West, which would be the whole left side of the border there. The Northeast, which would be here, or the South. Which do you guys think?
Northeast.
Yeah, Northeast. We have from Edison up to Patterson over to Newark to Jersey City. We have the most major cities there, okay? And then a little blurb here about the compass rose. You have the Northwest, East, and South, okay? So moving on, we're gonna actually do some application of this skill and then discuss it. We'll watch a couple of little videos to get a little more detail on some of this information. So we are gonna look for again, the directions we're looking for the best answer. You could have 2 correct answers. Which one is better? That's the key. That is one of the biggest test-taking skill sets that I think you can learn, is that you may see the right answer, but you're gonna wanna read everything first. All right, let's look at this. Based on the map, we're looking at the map of Australia. We have the major cities here. We have that little key for the amount of miles, 0 to 500 miles. Based on the map, which statement about Sydney is accurate? Sydney is the capital of Australia. Okay, Sydney is located on the west coast of Australia, or Sydney is east of 150 degrees east longitude, and Sydney is north of 30 degrees. And we have Deanna just popping in. Let me write her down too. Okay, so which is the true statement? Okay, is Sydney the capital?
No.
No, why? Because we can see that would need to be a square, not a square, a star.
Star.
It's been a long day. So I'm Xing that guy out. That's not it. Sydney is located on the west coast. So we know our what the heck is this thing called again? Compass rose. Your compass here, this is the east side. This is the west side. Are we on the west coast? No, Perth is, okay? So that's not it. Sydney is east of 150, okay? So Sydney, here's 150, goes all the way up here like this. Is Sydney east of that, which would be to the right, or west? So that is potentially the answer. So that's a possible answer. Is it north of 30 degrees? This is the 30 degrees south latitude. Is it north or south? North would be above, sometimes we call it, or below. It is below, so it's actually south. So this is an incorrect. Oops, what did I do? Incorrect as well. That's not what I want to do. I just want to cross it out. Cross it from the bottom. There you go. So we took the time. We got that one definitely correct. Now, based on the map, what can you assume about Australia? Most of the cities are located north of 15 degrees south. Most of the cities are located along the coast. All right. Most of the cities are located between 105 east and where most cities are located.
You got me? What? You give me my mind, I'm saying. Are you ready to go tight?
I cannot hear a thing.
Yeah.
No, you.
I know.
I can't hear anything. Listen, Beth.
There we go. So
There we
a
go.
little muting. Sorry about that. I'm super good with this technology too. All right, so we're looking at most of the cities. So we would say that most of the cities are here. Are they located north of 15 degrees south? This is 15 degrees south. Most of the major cities, only Darwin is, okay? So that's not right. Boom, not right. Most of the cities are located along the coast. Coast. That's potentially right. I might agree with that. Most of the cities are located between 105 east and 120. That would be over here. Only Perth is, so that's not it either. Most of the cities are located between 0 and 15 south. So from 0, we can assume is up here, and 15 south, that would be only Darwin. Most of the cities are specifically located on the coast. Did you see how we got that? Pretty good. All right, so number 3, we conquered. According to the map, which 2 cities in Australia are located the farthest apart? So let's look at it, get a visual. Which are the farthest apart? You could say maybe Perth or Darwin, maybe Sydney and Perth, because I think that's the farthest west, and this is the farthest east. Let's see if we got it right. Sydney and, well, I guess we need to read it first. Perth and Adelaide. So Perth and Adelaide are here to here. And then Perth and Melbourne, that's farther. Perth and Melbourne are farther than that. And then Melbourne and Sydney, they're fairly close to each other. And Sydney and Darwin. I think our best answer is going to be Perth to Melbourne, B, okay? All right, let's look at this one. Georgia highways, that's really fun. Make sure you do not speed. That's one of the only speed traps or places I actually paid for a speeding ticket. They just love taking Floridians' money. All right, we're studying the map. We're choosing, again, the best answer to each question. Which interstate highway runs through Georgia's capital? So we have the capital here. Is it 19? So we can assume 19 does, okay? So that's possible. How about 95? 95 goes up like this. That's not even touching. So that's dumb. How about 16? Number 16 goes, 16 turns into 75, so it stops right there. 16 doesn't exist after that point in Macon.
That'd
Boom.
be 75.
Could be 75 as well. Let's look at 75. So we need to look at 75, and it does go through, but so does 19. So now we have, oops, I can draw. We have 2 roads that we know of that are possible, okay? But it asks us something specific. What interstate highway, okay? 19 is a US highway. 75 is an interstate highway. There's a difference. 19 has lights. That's a difference between the two. 75 does not have lights. Do you get the difference there?
Yeah.
So we have to select, oops, let's just trash it. Our answer has to be 75. Did anybody is that a little confusing to people?
No, because I've been there.
Well, you've been there, but I'm just trying to show you that you really have to analyze. You have to totally analyze what's going on with the actual question, because you can read through that and you could see 19 and go, yeah, heck yeah, 19 goes straight through that, and you didn't read that right because interstate highway versus U.S. highway. Okay, which city is near Interstate 16 and 95? 16 and 95 would be right here. I got to go with Savannah.
Yep.
Savannah. Which city absolute location is closest to, we have 81 west and 32 north. So 81, so 32 would be here. I'm looking at 32 north, all the way across there. And then 81 goes up like this. What do we touch again? Savannah.
Oh.
Savannah. Which part of Georgia has the highest population density? Okay, so we're looking in the highest population density. So basically what we're looking at is cities, city-wise. Are they north, north central, south, or east? I'm not saying south. I'm not saying east. You gotta probably say north central, okay? Just to narrow it out there, okay? So we're not gonna look at physical maps, but we will switch back to, crap, there we go. All right, so let's exit out of here. I have any new people that came in, we're good to go. Sheila did, so let me get her down. Okay, let's move to, I wanna look real quick at, and I'll go actually right back to this real quick. I'm going to send you guys this. This is an image that we're going to look at. This is the world in regards to our MERCATOR projection. Let me share now to Safari. Okay. I want to preview really quickly. You can see this?
Yes.
Okay.
Yes.
So I would like to preview really quickly the article that I just assigned. It is the 5 themes of geography that help organize how we study our planet. First, we must look at location, and that's what we're going to basically look at today, relative location and then absolute location. And what we're going to look at is, and I'm going to try to draw this at some point, is latitude and longitude, why we use it, how we use it, what's the purpose, okay? A bunch of different objects here that we need to look at for sure, okay? So as we do that, I want to have a couple of videos that I want to look at. And we're going to discuss longitude, latitude, as well as why we have seasons. Why in the heck do we have seasons? So we're looking real quick at this one. I'll send, I think, most of these to you guys in my email tonight. We're not going to watch all of them.
Writing's not that easy, but Grammarly can help.
Grammarly.
This sentence is grammatically correct, but
What happened? Oh, paused.
lines of latitude and longitude intersect
Oh,
at the
oh,
equator.
There we go.
Oh, my keys are on.
I need you to go back to the beginning.
It's estimated that the Earth is over 4.5 billion years old, and that modern humans have been walking the face of it for around 200,000 years. The geography of our planet has shaped the population patterns, available resources, industries, cultures, and nearly every facet of human activity during those 200,000 years. Geography is a study of the physical features of the Earth and how they affect the humans who call the planet home. Physical features include landforms like valleys, mesas, mountains, deserts, volcanoes, and canyons, along with waterfalls.
Nobody has teeth, right?
To pinpoint locations on Earth, geographers use either relative location or absolute location.
We talked about that,
location is
relative.
where a place is located in relation to another place.
So we could say
Treasure is
like
located
North America is north of South America. I mean, that's as easy as it gets, right? That's kind of relative location. And then exact would be we're at 32 degrees in 7 minutes of latitude north and 45 degrees of longitude east, and you'll get a pinpoint, an exact location.
the palm tree forest. Absolute location is the precise point where a place is located on Earth. To find absolute locations on Earth, a geographer uses imaginary lines called latitude and longitude. Lines of latitude circle the Earth from east to west, while the lines of longitude circle the Earth from north to south. Geographers measure latitude and longitude in degrees. Each degree of latitude is about 69 miles or 111 kilometers. Degrees of longitude work a bit differently. The lines converge at the poles and are widest at the equator, with a distance of approximately 69 miles or 111 kilometers at that point. Lines of latitude and longitude intersect at right angles at the equator. The equator is the line of latitude that divides the Earth into the northern and southern hemispheres. At 0 degrees latitude, all locations north of the equator are written as N number of degrees. All locations south of the equator are written as S number of degrees. Lines of longitude begin at the prime meridian, which divides the Earth into eastern and western hemispheres. At 0 degrees longitude, all locations east of the prime meridian are written as E number of degrees. All locations west of the prime meridian are written as W number of degrees. People are using the lines to crisscross the world every day. Ships and airplanes need to use the coordinates to navigate the oceans and skies, while travelers use the lines of longitude and latitude to find specific landmarks. You can use the lines of longitude and latitude in your own community to go geocaching to find treasures hidden where you least expect it. Studying geography allows us to understand the reasons people live in various regions, how physical features affect the economy of communities, and on a larger scale, global political issues like border disputes, climate change, access to food and clean water, and the spread of diseases, just to name a few. Jumping into the world of geography is as easy as opening a GPS app on your smartphone and putting one foot in front of the other. So what are you waiting for? The world awaits.
What are you waiting for? So now we want to understand that lines of latitude and longitude, and then we want to understand that we're spherical and we have an axis, okay? And we'll discuss that in a little bit. And we want to really understand why we have seasons, just because the other day we just got into the season of fall, okay? All right, so let's continue.
Do your students like watching explosions, cute animals, and
Well,
awesome
duh.
science experiments? Then they're gonna love Generation
Exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. Winter, spring, summer, fall. Seasons. I just love them all. Other than inspiring me to make up goofy poetry, why wouldn't you love the seasons? There's always something to look forward to. You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of Frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet, Earth, revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you've ever sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. bright and intense. Now move the flashlight down at an angle and point it at the top of your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight we get in winter. But what about spring and autumn? During these two seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature in each month for 1 year in Toronto, Canada, where I live. Looking at the graph, we see that during December, January, and February, when the northern hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
All right, so let's look at one more.
I need a number drink, Surrey.
What?
I need a number drink, Surrey.
Are you guys done? Oh,
No, we are not done.
okay.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons aren't reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continents. During winter, continents in this view turn dark from a lack of photosynthesis.
All right, cool. So we want to, I'm going to share this. I will print this out for you. We want to look at a couple of things. This is your world map, okay? We look at the equator over here. That's 0 degrees, okay? North and south, 0 degrees. That's our first, or the belt of the earth you can think of as latitude, and I'm going to draw it here in a little bit. Then we have our suspenders, I think of as lines of longitude. Our first one is called the prime meridian, okay? And then we have an interesting at 23.5 degrees, 23.5 degrees north, we have the Tropic of Cancer, and then we have the Tropic of Capricorn, 23.5 degrees south. This is where the sun will shine. No other direct sunlight, at least. Okay, these are called the tropics. Okay, this is the hot zone. We're almost in it. Okay, and you felt that today. Tomorrow should be better though. Then we have at 66.5 degrees north, we have the Arctic Circle. A lot of ice up there. Okay. This is where there is definitely no direct sunlight, but the smallest amount of direct sunlight. And then 66 degrees south, you'll have the Antarctic Circle. It's not pictured here. And I don't know why, because Antarctica is not on there either. Okay, so let's hopefully, and you guys can help me out with this. What I'll try to do is try to set up, and hopefully it'll work. But now I'm having a brain fart. It's having a brain fart. Can you see me? Anyone? So this is the internet. Yeah. The internet connection is unstable. Love it. Internet connection. Very. Can you see me? Can you hear me?
Yes.
Yeah.
Yeah.
So
Yes.
this is where you guys can write. You can write notes. I'm gonna edit it just a little bit like that. You can write notes. We'll get you set up for a couple of basic terms. All right. So we will draw our first Earth, and we're gonna know that these lines. Okay. Do you remember what they were called? They run north and south. They're called lines of what? What do you guys think? These are longitude. And they are north and south and measure east to west. Okay? Same idea here. We have our equator, and we have these lines that run. You think of them like a belt versus the suspenders I think of as longitude. This is latitude. All right. They run east to west and measure north to south. Okay. Big idea there is I think of your lines of latitude or your belts. All right. I had a teacher in like 6th grade. He called it latitude fatitude. Your belt keeps your pants on, and your suspenders, same idea with lines of longitude. Okay, so let's try, see if I can get a good angle here. It's not very, that is the Earth. A little blue, some green, we have going on there. So if you didn't know, we do not float in space at 0 degrees. Okay? If we did, we would either burn up or freeze depending on where we would be on the Earth if we spun directly like a top. We do not. We actually are 23.5 degrees at an angle. Okay? That'll be our midpoint, okay? That's our actual, this is where the North Pole is and the South Pole is, and that's at 23.5 degrees of an angle, okay? Therefore, our line of latitude, that's a lovely noise. Line of latitude, there's the equator, okay? And then we can call this is, latitudes are called meridians. So the prime meridian, which would be at 0, north and south, would be our prime meridian. And you guys can look at this later if you want to. Then we have this special, I'll dot this, let's go a different color. Let's go orange. Orange is gonna be, we're gonna look at our tropics. And this is not perfectly to scale, obviously. So this is our Tropic of Cancer. And this is our Tropic of Capricorn. Okay, and that's at 23.5 north and 23.5 south, okay? So right now, we are, the sun is literally touching the equator because we're in fall, okay? So you can think of, we'll do spring, they call it equinox. Your summer solstice. Your fall. And then your winter. And you can think of this as, it's always, this is 321, this is 621, this is 921, and it fluctuates based on whether or not you have a leap year. But the 21 or the 22nd of the 3rd, 6th, 9th, and 12th month depends on where the sun is directly hitting. So right now we're directly hitting in an equinox. It hits the equator, okay? It's exactly on the equator. This is why we have 12-hour days, 12-hour nights, okay? When we were in summer, 621, that would be our longest day, okay? That's our very, very longest day. That's when you can go fishing at the beach till like 9 o'clock at night, okay? Because the sun is hitting at the Tropic of Cancer in the northern hemisphere, okay? And you want to think also, when you're in the northern versus the southern hemisphere, you would be opposite, you'd be opposite seasons. So right now in Florida, we're getting into fall, right? Coming out of summer, going into fall. If I was living, I lived in Argentina for a year, I was at this time going from winter, so taking off my heavy duty jackets and moving into spring, okay? That's why where you get like Christmas in July. In the southern hemisphere, it's literally winter, okay, in July, all right? Let's go real quick and draw up here our, at 66.5 north, we have our Arctic Circle. And then 66 south, we have our okay. So I know that was a lot of drawing and a lot of information, and I'll leave that up like that. Is there questions, comments about that? I think you could. I will send you a bunch of videos that add to this information, but this is kind of the basics of what we're looking at specifically if we're trying to do look at a specific area. Okay, so we want to know this terminology, this information. Okay, it's very good. So if you need to, you can screenshot or go back and look at the video at that point in time, but I will move back to the regular part of my desk. All right, so questions, comments for me, we're at 50, at 5:50, so we are essentially done. Questions, comments, what do you guys?
So for that map, do we need to generally know everything on it for the GED?
You went out, I'm sorry.
Do we need to know everything on that map for the GED?
Know everything on the map. It's very good to know the different parts for sure. I'm not guaranteeing, because the GED has thousands and thousands of questions that they rotate in and out. So you could very possibly have something that would be exactly like that. I definitely think, like when we talked about looking at the parts of a map and being able to identify, and like that little practice we did today from the test book, you're definitely going to see something. You might see a map. It might not be a world map. It might not be a globe like that. Thursday, we're going to talk about the difference between a globe and how we draw a globe. We're taking something spherical, 3D, and then we're putting it on a flat piece of paper. That no map is perfect, because you can't, it's physically impossible to do that. And we'll talk about which ones are better, which one's worse. We're going to look at how that Mercadian one might be actually racist. It might be racist. And we'll look at how is a map racist? And we'll look at how it makes Europe look in comparison to Africa or things like that. So we'll actually be able to, we're going to use this cool website that I can take any country and measure it up to other countries, okay? The Mercadian, and I'll show you, let me show you just real quick. I'll go on a real quick tangent. You see this classic Mercadian, nothing's wrong with the guy, it's this guy's last name that made this map, and he tried to make this in quadrants so we'd be able to get from Europe to the rest of the world, okay? But Greenland right here, Greenland looks almost the size of Africa, right? It makes Europe look big, right? Greenland, it can fit into Europe 14 times. So I'll actually be able to show you, and I'll be able to drag Greenland over here, and you'll be like, okay, it's not that big, okay? It's just skewed because that's how we drew that map. Again, you're looking and you're trying to understand something that's a sphere and draw it out on something flat, which is very, very, very difficult to do. All right, okay. So any more questions, comments? I would definitely check out the article that I just posted for you guys on Newsy There's a whole section on IXL as well that you want to check out if you're looking at latitude, longitude. Just type those buzzwords in, you'll be able to do them, okay? All right, my friends, if...
I have a question, Mr. Turner.
Yeah, please.
You was telling us about the IXL, the diagnostic.
Yeah.
Now, how do we get to our name at the bottom to actually get credit for what we're doing?
How do you get to the name at the bottom?
Yeah, you had, before you showed it, you had all of our names at the bottom screen. You said your name is in black. You have to hit on your name.
Oh, that just shows me as a teacher who's doing it, who's not. So continue doing those questions. Even those of you who are quote unquote done with your diagnostic, every month you should take some time to do your diagnostic so you increase that score, okay? And then you have more skill sets to specifically work on.
Okay, now if we already passed the language arts, how do we go to the next subject? It always showed me just the math part.
You might have clicked on just math then. Yeah, you should be able to do language arts even by itself if you want. And you're frozen. I know you're trying to speak. Oh, internet connection. All right, my friends. You got 7 minutes. I will spend the next 7 minutes praying for you and your math. I wouldn't want to be there. All right, my friends. We'll see you.
Okay, bye.
Bye.